Right, we have this question in front of us, and we need to find the unit tangent vector t of t at the given point on the curve r of t equals the trigonometric sine of t by the unit vector I plus 5t times j plus cosine t times k, where the I, j, and k are unit vectors at the point 0, 0, and 1. B, we have the vector r of t equals the first component, t cubed plus 1. The second component is 3t minus 5, and the last component is 4 over t, and we have 2 minus 2 and 4. Right, so we need to solve this particular question. And to solve this particular question, we proceed as follows. Right, so the couple of things that we need to consider here. So first things first, we're going to proceed to discuss and define a unit tangent vector. What is a unit tangent vector? Right, to define that, we begin as follows, and we say if a smooth curve is defined is defined by, right, you can define it as the vector r of t, which equals f of t, g of t, and h of t is the third component. Or if you don't want to define it like this, you define it as r of t, which equals f of t times I plus g of t times j. Okay, so in other words, we have that the I, the j, and the k are our unit vectors. Right. And then we have plus h of t, which is the unit vector k, like so. So if a smooth curve is defined by this or that, the unit tangent vector, can write a little bit below here. Right. The unit tangent vector is defined by, right, is defined by the vector t, which is the vector r of t divided by the length of the vector r of t differentiated. So yeah, we have the derivative at the bottom here, as much as this is the derivative. Okay, so just note that. But obviously in this expression of the unit tangent vector defined like this, we note that at this point, the derivative of the vector r of t is never 0. It should not be 0. Okay, so we have defined the unit tangent vector. So what do we do next if this is the prime and that shows the derivative? We give an example. Right. We give an example. Right, we're going to give 2 examples. But first, we give the first example. Right, the first example is the one we gave in part A. Right, which is the trigonometric sine right, of t at the point 0, 0, 1, and we attempt to solve this problem, but not just to solve this problem, but to solve this problem step by step, right? And we proceed as follows. Right, so we have that r of t is exactly the same as the sine of t by vector I, 5t by vector j, cosine t by vector k. Okay. At the point 0, 0, 1, we need to understand a couple of things, that these points, I mean 0, 0, 1 here, we need to understand that this point here is actually in the Cartesian coordinate system, where we have x of t, y of t, and z of t. And now, if these are the components of the point, it means a couple of things, but it means at this point, it means that the sine of t is 0, and it means that 5t, okay, it means that 5t being the second component equals 0. Simultaneously, cosine t equals 1. Solving for t, we can see that t equals 0 here. Dividing by 5 means t equals 0 here. And here it means t equals 0 as well. So this can be seen as, and we can then say that hence the vector r of t is the sine of t I plus 5t j plus cosine t k, and this is performed at t equals 0. So with this said, what is the unit vector here? What is the unit tangent vector? Right, so the unit tangent vector t of the variable t is given as follows. R primed of t, R primed of t, which means we have this. Right, obviously, we note a couple of things here. That the vector r of t is not 0. Right, the vector r primed. Right, so the vector r primed of t is not 0. Okay, let's say that is the case. Just to make sure that there's some easy way to follow here. With the vector r of t equal to the sine of t I plus 5t j plus cosine t k cosine t k. And so on this is at t equals 0. And then it means therefore the vector t, the unit tangent vector, is the derivative of this. What is the derivative of this? The derivative of the sine is cosine ti plus 5j minus the sine of tk And then now you divide these by the length. Cosine ti 5j k. And this is exactly what we have here. And so what is the meaning of these here? So these can be seen as exactly cosine ti plus 5j minus the sine of tk. And in the denominator, then we have cosine squared t plus 5 squared plus the minus sine squared. And what do we do here? We put the square root like this. And now with that said, what do we obtain from these here? What do we get? So it then means that for the part A, still we are finishing the vector t of t is exactly the same as cosine ti plus 5j minus the sine of tk divided by. Right, so if you look very carefully and you have cosine squared plus sine squared. So we have cosine squared t plus sine squared t plus 25, like this. Okay, and what is the meaning of this? What is the meaning of this? Right, then it means that the vector t. Okay, now cosine squared plus sine squared is what? Is 1. So that you have 1 plus 25, which therefore becomes the square root of what? Of 26 into cosine ti plus 5j minus the sine of tk. Right, so we evaluate these at t equals 0. This implies that we have t of 0, which is 1 over the square root of 26. And then we have the cosine of 0i, 5j, the sine of 0k, which is 1 over the square root of 26. So cosine 0 is 1. So that what you get here is what? Is I plus 5j. Okay, sine 0 is 0. Right, so we have this exactly. We have this exactly. Right, hence the unit tangent vector is given by this 1 over the square root of 26 into I plus 5j. Unit vector I plus 5 unit vector j. You can do a check to see if this is indeed a unit vector. So you get its length, the length of the vector, Right, getting the length of the vector will be 1 over the square root of 26. 5j, like this. And then you can take out the 1 over the square root of 26 because it's positive, and then you get the length of the this vector. So the coefficient of the vector I is 1 squared plus 5 squared. So this is 1 over 26 square root 26, which is 1. And thus we have that the actual length of this vector is 1 unit. What does that confirm? Well, it confirms that this indeed is a unit vector. Not only obviously a unit vector, but it is a unit tangent vector. Okay, right, so that was the part A, and then now we're going to look at the part B. Right, what is the part B? And now we need to do the part B of our set of problems. So that one is the vector R equals R of t equals the t cubed plus 1, 3t minus 5, and then 4 over t. So if you look at it, then we'll deal with C now, rather B. Okay, the vector R is given with the pointed brackets, t cubed plus 1, 3t minus 5, 4 over t at the point 2 minus 2, 4. At the point 2 minus 2, 4, like this. At this point, I mean, if you're given these, this means that t cubed plus 1 is 2. 3t minus 5 is minus 2, equal to here. So this one is an equal sign. But it also means that 4 over t is 4. Okay, so you equate these vector components to the components at that point. You want to evaluate at this point. So now this means you have t cubed equals 2 minus 1 is 1. Here you have 3t equals 5 minus 2, which is 3. And what else are we able to achieve? We're able to achieve that we can be able to get t. T is 1 here, 4 cancels, etc. Moreover, here we're getting t equals 1, t equals 1, and t equals 1. Well, obviously that's what we expect. We expect t to be the same value. All right, now we're able to sort of write a conclusion. Hence, the vector R of t having t cubed plus 1, 3t minus 5, and 4 over t at the point 2 minus 2, 4 is actually can be seen as computed at rather is the vector defined at t equals 1. So these are just the same thing. With that said, then we can get the unit tangent vector. Part B. R of t. T cubed plus 1. 3t minus 5. 4 over t at t equals 1. Okay, so now we can be able to get thus the unit tangent vector is given by t, vector t, which is r primed of t divided by the length of r primed at t. Right, so you take the derivative of this, which is 3t squared. The derivative of this is 3, and the derivative of this is exactly minus 4 over t squared. And then now you divide by the length, like this. Okay. B part. Okay. T. So we have 3t squared. 3 minus 4 over t squared. So you have 3t squared, you square it. Okay, and then you have minus 4 over t squared, and you square this, which means the unit tangent vector as a function of t can be seen as 3t squared, 3 minus 4 over t squared, like this. All right, so which is 9t to the 4th power. 9 plus 16 over t to the 4th power. And now what is all this here? What do we do with all these here? As a matter of fact, so we're able to look at this and analyze this with much caution. Remember, we are still looking at part B, so that this vector is the 3t squared minus 4 over t squared. We divide by 9, t to the 4th power, 9 plus 16 over t to the 4th power. This is a t equals 1, so that this vector here so you have this squared 3 minus 4 over 1 squared. Which is 9, 1 squared plus 9, 16 over 1 to the 4th power. And this is 3, 3 minus 4. And this is divided by the square root. It's divided by the square root of 34. The question obviously we continue to ask is that, so in other words, here we can then say hence. Our t primed of 1 vector is not primed. Right. It's not primed here, just the vector t. Right, so now this vector is actually 1 out of the square root of 34 3. 3 minus 4. So now, let us continue to check this vector. Let's check if this vector is a unit vector. Check. So we're going to proceed to do a check. Which is t of 1. Which is 1 over the square root of 34. Three minus 4. Which is 1 over the square root of 34. And this is 3 squared plus 3 squared plus minus 4 squared. Which is 1 over the square root of 34. And what is the square root of these? 3 squared is 9 plus 9 plus 16. And this is exactly the square root of 34 because 9 plus 9 is 18 plus 18 plus 16. 18 plus 16 is 34. Divide by the square root of 34. And the result is 1. Hence, we have that. We have that. So that is the answer to this. That is the answer. So the conclusion is therefore obviously this is the case. And what is this? Is actually the unit tangent vector. For part B, and for part A, we have seen that this one here is the unit tangent vector. Okay, is the unit tangent vector. Right, and we have solved this problem in detail. We're done. Thanks everybody for your time and attention, and goodbye to you.